Okay, Trig kids, this is section 8.3. If you're gone for Actions Day, you are watching this video. I did this with the kids who were here yesterday, and now I'm doing it again with you guys so you get the really shortened version. We've already figured out all of the answers to these problems, so I won't have to waste time plugging stuff into my calculator. Solving these problems, and example 1, 2, 3. Whoop, let me shut the sound off. Example 1, 2, 3 are going to go by really, really fast. Okay, so cosine x, you already know how to solve this. I want to get rid of the cosine, keep the x. The x is trapped inside of cosine. So how do I get rid of the cosine? I do the inverse cosine. On your calculator, you have an inverse cosine button, which is probably just shift cosine. X equals inverse cosine of 0.6. Now, on these problems, you need to make sure that you are in radians, so your mode needs to be in radians, and you will get something like 0.927. If you want to pause this video and make sure that that's what you got, that would be a really good idea. But make sure you're in radians because they want the solution, they want the x that you're trying to solve for in radians, okay? There will be a couple homework problems where you are, I think it's like when it talks about the angle of incidence and the angle of refraction and stuff like that, where they're doing like, I don't know, sine of 17 degrees, okay? If you're plugging something in degrees, you need to make sure your mode is in degrees, all right? Otherwise you're going to get the wrong answer. So here we're wanting to find radians. Here, you're plugging stuff in degrees, so you're solving for degrees, okay? So example 2, x is trapped inside of sine. We want to get the sine to go away, so we do inverse sine, inverse sine. So x equals inverse sine of negative 0.75. And when you plug that in to your calculator, it is something like negative 0.848. Okay, again, that is the radian solution to that, okay? What this is basically asking on example 2 is, here's my sine graph. You don't have to graph this necessarily. Here's my sine graph, and it goes on forever, blah, 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 okay? They want to know where my graph hits at negative 0.75. Here's negative 1. They want to know where it hits negative 0.75. So here, 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 also back this direction, blah, 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 here and here, okay? Now, when we graph these to find the solutions, okay, like we did in section 8.1, you would have to do like the plus blah, 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 plus 2 pi k, plus pi k, blah, 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 whatever. When we're doing algebraic solutions, I'm not going to have you guys do that, okay? That's going to take forever, and it's going to make these a lot more complicated. So when you are not looking at the graph, when I ask you just to solve it algebraically, I only need the one solution, all right? So example 3 is that same way. They want to know what x-coordinate will reach 3 on the y-axis for tangent, okay? So solving algebraically, you just do inverse tangent of both sides. X equals inverse tangent of 3. In radians, you should get 1.25. Yeah, 1.25. Now, if your mode was in degrees, it should be something like 60 some degrees, maybe 60, somewhere between 60 and 70 degrees, maybe, is what you should get for 1.25 radians. That's what the equivalent is. So if you were in degrees, you probably got this as an answer, right? But they want, if they don't specify, they want it in radians, all right? If you're plugging something in that's in degrees, you need to make sure you're in degrees, right? Down here, this box is talking about the plus 2 pi k and blah, 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 but I'm not going to have you guys do that for algebraic solutions. I'm totally getting rid of that as a part of the homework. So you're welcome. That's taking a huge headache away from you, all right? Backside. Those front 3 problems were very, very, very easy. On the back side, it gets a little bit more complicated, okay? So you're solving for x. We want to get rid of everything except the cosine. So I'm going to add 1 and divide by 8. So basically cosine x equals 1 over 8, okay? Then you just do inverse cosine like we were doing before. So inverse cosine of 1/8 is something like, let me flip over, 1.45 radians. Okay, if you type that in, you'll get 1.45. All right, now, example 5, I want you to use your unit circle whenever you are able to. I do not have a 1/8 on my unit circle. Okay, there's no place where the x or y coordinate is 1/8. So I only have the option of plugging stuff into my calculator. Okay, on this one though, square root of 2 over 2 does appear on my unit circle. Square root of 2 over 2 does. So what I'm going to do is I am going to look, it says without using a calculator, that's when you know you need to use your unit circle. So I am looking for on my unit circle where the y coordinate, because that's what sine is, where the y coordinate is the square root of 2 over 2. Okay, on the unit circle there are two places. The first one is at pi over 4. If you look there, it's the square root of 2 over 2. And also at, let's see, 3 pi over 4, I think? 3 pi over 4 is where the other one is. So when I do inverse sine, and like I figured that out, I do pi over 4 as an answer, and I do 3 pi over 4 as an answer. Now, these are not the same thing as what you were doing when we were doing like inverse sine. Remember I said that, you know, you only use this answer because inverse sine only works in the first and fourth quadrant. But this was sine to begin with, okay? If they would have started the problem as u equals inverse sine of square root of 2 over 2, then the answer would only be pi over 4 because I'm starting with inverse sine. Here I'm just using inverse sine to get to square root of 2 over 2, okay, or to get to u. So this one will have two different answers. That's different from what we did in section 8.2. Here I'm just looking at the graph of inverse sine. Here I'm using inverse sine to get the original sine, so there will be more than one answer, all right? So that's a little bit confusing. So pi over 4, 3 pi over 4, I'm not going to have you put the plus 2 pi k and blah, blah, blah on the end of that, okay? Not for this section, not when you're solving algebraically, all right? Now, we know this information. We know that sine of some value of square root of 2 over 2 occurs at pi over 4 and 3 pi over 4. But now they want sine of 2x, okay? So how do you deal with it when it has a 2 in there? So what I'm going to do is I'm going to just ignore that 2 for right now. Just ignore that he's there. We're going to solve and figure out where the sine is square root of 2 over 2. And we've already determined that it's at pi over 4 and 3 pi over 4, okay? So I know that it occurs at pi over 4 and it occurs at 3 pi over 4. So x is pi over 4 and x is 3 pi over 4. Except it's not just x anymore. It's actually 2x and 2x, okay? So now that I have found the answer to the inverse sine stuff, now I can unravel and do the 2, okay? I want to do the inverse sine first to find the pi over 4 and 3 pi over 4, and now I can divide by 2. So I'm going to divide by 2, divide by 2, divide by 2, divide by 2, okay? So x over here is going to be equal to pi over 4 divided by 2. And 2 over 1 is that as a fraction, so it's kind of like multiplying by 1/2. So pi over 4 times 1/2 is pi over 8. That's what that solution is, okay? Then I'm going to divide by 2, divide by 2. This is divided by 2 over 1 or multiplying by 1/2. So I have 3 pi over 4 times 1/2, which is 3 pi over 8. And those are my two answers now, okay? So I still want to do the inverse sine and figure out where he is the square root of 2 over 2, and then I deal with this 2 being in here, okay? All right. If that was too fast, rewind. Example 7. You are going to use some factoring to solve this problem. So 3 sine squared minus sine squared minus 2 equals 0. Okay, that's a lot of sine-y stuff and blah, blah, blah. So I'm going to change this. Instead of doing sine, let's do x's to start with to factor him down, because that makes it a little bit easier for me to think about. And then we'll change it back to sines at the end. So I have 3x squared minus x minus 2, and that's a trinomial, and I have to break him down. So this is going to be a Cody's method trinomial, a complex trinomial because there's a 3 here. So I take 3 times negative 2, which is negative 6, and I want to multiply to get negative 6, but when I add them, give me this middle piece, which is negative 1. Okay, that's going to be negative 3 and positive 2. Right? So now I rewrite this whole thing again. 3x squared minus 2. Those two pieces stay the same, but this middle one breaks down into 2 pieces. Minus 3x plus 2x. And I've got that middle piece going on there. Now, I factor by grouping. So group, group. Here I can pull a 3x out, and I'm left with x minus 1. Here I can pull a 2 out, and I'm left with x minus 1. Okay, so my two pieces are x minus 1 and 3x plus 2, except they're not just x's. They are actually sine x minus 1 and 3 sine x plus 2. Okay, now I set both of those equal to 0. So sine x minus 1 equals 0. So sine x equals 1. Okay, this one, if I set that equal to 0, I'm going to subtract the 2, divide by 3. Okay, if I'm going too fast for you, rewind this. minus 2 divided by 3, negative 2/3. So I can find on my unit circle, because I do have ones on my unit circle, I can find where sine, or the y-coordinate, is at 1. So unit circle, where the y-coordinate is 1, up here, that is at pi over 2. So I know pi over 2 is going to be one of my answers. Right? Now sine of negative 2/3. There is no negative 2/3 on your calculator, or on your unit circle, so we have no choice but to inverse sine them. Inverse sine of negative 2/3 is something like negative 0.729. And then again, that's in radians. So I have two answers. One of them comes out nice with my unit circle pi over 2, and then the other one is a decimal, which is fine. Okay? All right, a couple more factoring ones. This one, tangent cosine equals tangent. All right, I've got some tangents and cosines going on. Those are two different trig functions, so I'm going to, if I were to try to solve this by graphing, I would maybe set like y equal to this, and then another y equal to that, and find where they cross each other. Or maybe you are like Jazz, who likes to put the tangent onto the other side and set this equal to 0, right? So that's exactly what we're going to do to factor this thing. We're going to get the tangent over to the other side. Now, both of these two pieces have a tangent in common, so I'm going to pull a tangent out. Okay, and left over is cosine squared x minus 1 equals 0. Okay, now that I have him completely factored down, I still set both pieces equal to 0. So I'm going to say tangent of x equals 0 and cosine squared x equals, or minus 1 equals 0. We're going to move that 1 here in just a second. So on the inner circle, where does tangent equal 0 at? Tangent equals 0 at 0, I think, and also at pi. Check that on your unit circle. I'm pretty sure that's right. Let me, hold on. Yes, at 0 and pi. So 0 is one of my answers, and pi is another one of my answers. Okay, both of those make tangent 0. All right. Now, cosine squared x minus 1 equals 0. I'm going to add 1 to both sides. So cosine squared x equals positive 1. Okay, now I have that square and I want to get rid of it, so I take the square root just like normal. So cosine x equals, the square root of 1 is plus and minus 1. So on the unit circle, I'm trying to figure out where cosine is positive 1 and where cosine is negative 1. Okay, cosine is the x coordinate. So the x coordinate is 1 over here and the x coordinate is negative 1 over there, which is again at 0 and pi. So my answers for the second piece are 0 and pi. Now, you only need to list them once because 0 and pi were my answers here. I don't necessarily need to list them twice, but both of those, setting both of those equal to 0 gives me the same answer. Okay? All right, example 9. We're almost done. This is another factoring one. So this is a Cody's method, except we have cosine and we have a sine going on. So we've got to do one thing first before we can Cody's method and solve this thing. Okay, cosine squared, sine squared, we have to use an identity. Okay, and anytime I see a squared value, I automatically think of the Pythagorean identities. So I've got a poster in my room that says sine squared plus cosine squared equals 1, right? So if I'm trying to get cosine squared by itself, I'm going to bump this sine squared to the other side by subtracting. So I've got cosine squared equals 1 minus sine squared. Right? If I bump that sine to the other side, I've got 1 minus sine squared. Okay? So I'm going to take this thing right here and plug it in for the cosine squared. I do that so that I only have sines going on. I only have one trig function. Instead of sines and cosines going on at the same time, I have one trig function. So again, this piece went in for the cosine squared. He went in here. And then I try to get rid of this parentheses by distributing the 10. So negative 10 plus 10 sine squared minus 3 sine x plus 9. There's really an x on this sign. Equals 0. Okay, so now I've got 4 pieces. This one, this one, this one, this one. I'm going through this really fast, so if I'm going too fast, pause it so you can finish writing. Okay? All right, so I've got those 4 pieces, and then I want to kind of put them in order, and this negative 10 and that 9 can go together. So I'm going to write 10 sine squared x, because that's going to come first, minus 3 sine x is going to come second, and then negative 10 and 9 is going to make minus 1 equals 0. Okay, now I have a trinomial. It's kind of like 10x squared minus 3x minus 1 equals 0. Okay, I like to switch them to x's. If you can do this without switching to x's, that's fine. Just know that you're going to have to switch them back at the end to signs, but it makes it easier to do the algebra and to factor that down when I just have x's to deal with. So I'm just kind of thinking about this in simpler terms. I'm not really getting rid of the sign. I'm just thinking about this simpler. So 10 times negative 1, this is another Cody's method, kind of like what we did up above here in example 7. Here's example 7, we're doing this thing again. Okay, so go down here. 10 and negative 1 makes negative 10. And I want to multiply to get negative 10, but when I add them, give me negative 3. That's negative 5 and positive 2. Okay, now I'm going to rewrite this. So 10x squared minus 5x plus 2x minus 1 equals 0. This guy split into those two pieces. The other two pieces stayed the same. So then I'm going to factor by grouping. Okay, pull out of this first piece like a 5x, and left is 2x minus 1. And out of the second piece, you still need to pull something out. It's going to be a 1, 2x minus 1. Okay, so my two pieces are 5x plus 1 and 2x minus 1, except they're not x's. They're actually signs. So 5 sine x plus 1 equals 0, and 2 sine x minus 1 equals 0. Okay, I'm going to set those two there. All right, now I'm going to solve. So I'm going to subtract the 1 and divide by 5. Sine x equals, subtract 1, divide by 5, negative 1/5. Okay, over here, I'm going to add the 1 and divide by 2, so sine x equals 1/2. I'm going super speed through this, so if I feel like I'm like losing you, please pause this a couple times, okay? I'm just trying to go through this kind of fast for those of you who can keep up, because I know some of you guys can do these super speed. So now I don't have a negative 1/2 on my unit circle, so I'm just going to, on my calculator, inverse sine, and you get something like negative 0.201. Okay, that's that answer. On my unit circle, though, I do have a 1/2. Okay, there's two places where sine is 1/2, and it's up here, and it's over here, and that's at pi over 6 and like 5 pi over 6, I think. So those are the two answers for inverse sine. Okay, my answers are pi over 6 and 5 pi over 6. So this entire problem has 3 solutions, basically. Okay. All right, there are actually many more than 3 solutions, but that would require you doing the plus 2 pi k on the end of it, and we're not going to do that. So those are the 3 main solutions that everything else stems from, right? Okay, on to the last one, example 10. We have a secant, we have a tangent, and then we have a number over here, okay? I want to get them all to be the same trig function, so again, I'm going to use an identity. And this identity is another one of the Pythagorean identities, like sine squared plus cosine squared equals 1, except this one involves secant. So on your unit circle, I know that you have a Pythagorean identity that says something like 1 plus tangent squared equals secant squared. Okay, so if I want to get rid of the secant squared, I'm just going to take this guy and I'm going to plug 1 plus tangent squared in for that. I can just substitute. Okay, so 1 plus tangent squared x plus 5 tangent x equals negative 2. I just took this guy and I plugged him in there for secant squared. I do that because I want them all to be, I don't know why I put tax. I want them all to be the same trig function. They're all tangents now. Okay, so I have 4 pieces, 1, 2, 3, 4 now, and I want to get them all on the same side of the equal sign. So I'm going to put them all onto the same side and write them in standard form. So I've got tangent squared plus 5 tangent x. If I add the 2 over to this side and I have that 1, it will become plus 3 equals 0. Okay, add the 2 over plus 1, plus 3 equals 0. Okay, now I have a trinomial and I want to say, what can you multiply to get 3, but when you add them give you 5? Right? This is kind of like saying x squared plus 5x plus 3 equals 0. What can you multiply to get 3, but when you add them give you 5? And there is nothing that you can multiply to get 3, but when you add them give you 5. So we're at a loss. Like, what do we do now? You are going to do the Pythagorean or the quadratic formula. So negative b, negative 5 plus and minus the square root. B squared will be 5 squared, which is 25, minus 4 times a is 1 times b or c is 3. So I've got that going on. On the bottom is 2a, so 2 times 1. Okay. 25 minus 4 times 1 times 3 is 12. So I have 25 minus 12. That's going to be negative 5 plus and minus the square root of 13 all over 2. Okay, now, we're not quite done yet. We want to figure out what those are as decimals. So if I do negative 5 plus the square root of 3 over 2, that's going to be negative 0.697. All right, I'm going to write it down here. Negative 0.697. And the other answer, if I do negative 5 minus the square root of 3 over 2, I get something like negative 4.3. Okay? Now, when you do the quadratic formula, that's like x equals negative 0.697 and x equals negative 4.3, except they're not x's. It is tangent x. Okay? So, if I'm trying to solve for x, I would do inverse tangent then of each piece. Okay, so inverse tangent of negative 0.697 is negative 0.609 when you do inverse tangent of that one. Okay, when you do inverse tangent of negative 4.3, it is negative 1.34. Okay, so those finally are my two answers that I get. Okay, so lots of computational things. Wow, what a freaking mess that is. There you go.